I don't know what Leetcode smoked before saying it's a easy problem. It's not. It's a medium problem. Cool. The problem simply says that we are given the root of a binary tree. As usual, if we are given a tree, so usually we are given a root itself, and we have to return the length of the diameter of the tree. Aryan, what is the diameter? So diameter they have defined of a binary tree. It is the length of the longest path between any two nodes of the tree. So if I take the tree and I can take any two nodes, and between those two nodes, the longest path between them will for sure be the diameter. So basically, I just want to have a tree and I can take any two nodes and then find the diameter. So that will be the and find the maximum distance between those nodes, and that will be diameter. And his path may or may not pass from the root. So it can be from any two nodes of the tree, and the length of a path between two nodes is represented by the number of edges. So if I ask you what is the length of the path between 5 and 3, it will be 1, 2 and 3. It is the number of edges between them, not the number of nodes. Okay, so very basic. Okay, as soon as we read the problem, very basic thing which comes in our mind is, Aryan, okay, he's asking us to choose any two nodes of the tree. So what I will do is, I know to choose, okay, I have n nodes in my tree. If I want to choose any two nodes, okay, there can be n square options for me to choose any two nodes. Okay, I choose n square options. Obviously I choose n square pairs, and as I have chosen those n square pairs, now my task is to find the distance between those two nodes. I can, okay, as soon as I have, let's say if this is my tree, like normal tree, and let's say I have chosen the two nodes like this, I've chosen these two nodes like this, then my task will simply boil down to, bro, simple, just find the distance between them. How I will find the distance? Imagine this as the root node, which means I will have to restructure my tree. Imagine this as my root node, and will start to do DFS until I reach my second node of the pair. Then you will see, okay, n square pairs you will form. Then for every pair, to find the distance between those two pairs, you will take again O of n time. So time will be O of n cube. This is a time which you will take. Now, can you improvise it? For sure you will have to, because O of n cube is very high, especially in terms of these kind of questions, and especially in terms of which are not DP related or which are tree related. Usually O of n is the time question which actually works, and maybe sometimes O of n log n. But let's say how you will improvise it. Okay, from n cube you will go to n square. Firstly, usually we think of going to n square. Now, how can we go to n square? Again, we want to find what? We didn't want to find the distance between every pair of node. We wanted to find the diameter. Diameter is the longest path between any two node. Now, if I ask you, bro, if you had taken this node and you were finding the distance between these two nodes, okay, like from here to here to here, you were finding a specific distance, bro, I asked you, like you had an option to increase the distance. Why didn't you increase the distance? Which means you would have for sure put it as the edge node, so that you cannot go left anyway. Okay, I increase the edge node, okay, then you increase this specific node, okay, then for sure this is actually the distance which you could have said, okay, it's the longest distance in this specific path. So earlier I was going on to all the n square pairs. Now I don't have to go to all the n square pairs. I will just do one thing. I will start off from the edge, like extreme edge node, which means, okay, which are the leaf nodes. I'll start from those nodes itself, and from those nodes I will do a simple DFS traversal and reach the any extreme nodes and find, okay, what is the maximum distance. So again, with this, now you have reduced, and you are not going to all the n square pairs. Now you are going to all the leaf nodes, which can be at max n. So it is n nodes you will go on to, and for every leaf node you will again do a DFS traversal, which is again O of n, to find the distance between from that leaf node, from this leaf node to, you can simply do a DFS traversal. Again, you might have to refactor this tree, because tree is usually from root to leaves, so you might have to refactor the tree, but that is, okay, a case which you can think of that you might end up doing, or you can do. Now, this is one option, which means, again, when I say refactoring the tree, I mean that it was the original tree. So when I ask you, okay, this was the node, then you can just simply do a DFS traversal. Okay, a DFS traversal from this node to this node to this node, and then, okay, the maximum distance from this node to this node. Again, Aryan, you asked to do for a leaf node. Yeah, bro, correct. So what you can do is you can do it from every node, because I said maximum leaf nodes can be n. So you can do it for every node, which means this node, this node, this node, which means every of these nodes can be a starting a node. So ultimately it can look like that, okay, I'm starting and doing from one of the leaf nodes, which is let's say 3, and then I'm doing a simple DFS traversal, DFS, and whichever is giving me maximum distance, okay, that will be my answer, because I can do a DFS from 4 also. So I can do a DFS, or it can go a DFS like this. So whoever giving me maximum distance, that will be my answer. So with this, you know that your time complexity is O of n square. Now again, O of n square still would not work depending upon the time constraints. Will not work. Now we have to optimize it. Now we will think of that how we can do that. Now, for you to understand much better, I have added a few things in the existing tree diagram which I showed you above. I added a node right here and right here, so as to make it a bit bigger, so as to explain the entire triangle. Now, what is again as soon as you want to improvise, we again go back and see the requirements of the problem. See the requirements. We just saw pairs. Earlier we just saw pairs, and then from those pairs we tried to build the answer O of n cube. Then we saw the diameter, and it is the maximum or the longest path between two nodes of the tree. So I just made the pair nodes, which means the two nodes, I made them extreme nodes, and that become the leaf nodes. Okay, now I again went back to my question to actually improvise it. What I want a diameter. What is it? A diameter. Diameter is the longest path between any two nodes of a tree. Now, just imagine how a structure of a diameter would look like. It would look like that a big path is being formed. Again, I don't consider whatsoever other nodes are attached to all the nodes of the diameter, but this will be how a diameter would look like. It will be the longest path. Now, if I try to visualize that, okay, I can consider this as a node, right? Again, that can be a root node or not. It's just a node. There will be a left part of this node, okay, because usually in a tree we have a left subtree, right subtree, all that stuff. So we can have a left part of this node, which means, okay, and again that left part should be the maximum left part, because it can happen, okay, that I have one more node attached to this node, which is this node. So you want the maximum left depth. Okay, I can get the maximum left depth. As you can see in this case, 1, 2, 3, and 4. 4 is the maximum left depth. Again, when I say depth, I mean edges, right? 4 is the maximum left depth. And the same way, I say 1, 2, 3, 4. 4 is the maximum right depth. So if I ask you, bro, if you can see visually from your eyes, this is the diameter. What is the diameter here? As in, what's the length of this diameter? You will say, oh, bro, you found the maximum left depth. You found the maximum right depth. Simply sum them up, because left depth, right depth, this is the entire diameter. So I can simply say my diameter will be maximum left depth, maximum right depth, and that will be my diameter, which is 8. Oh, did you think of something here? What happened? You had a node, you just found the maximum left depth. Aryan, but I am just finding the left depth, not the maximum left depth. Bro, you found the maximum left depth, because you saw, I showed you, let's say here also you have a node. If you if you have a node here also, then 1 and 2, this is also one of the depths, but still you went on and tried for the maximum left depth. What is the maximum depth in my left side? What is the maximum depth in my right side? And that can form the entire diameter for me. The same way I can do it in my code, that at every step I will check, bro, what is the maximum left depth I have, what is the maximum right depth I have, and then I can just sum them up to give me the current maximum diameter at this specific node. Again, they can be many other nodes. They can be, okay, his parent also, his parent also, his child also, his child, and all that stuff. I will just keep on computing that at every step, which means, Aryan, will you do and find maximum left depth and right depth at every node? Then at every node you will take again O of n time? Nah. I will actually think of something that I can store that and deliver that to my parent. How? In a simple, that's the reason I told you that it is not an easy problem. It is actually a medium, because in all these concepts are involved in which you have to return the value from the child to the parent for him to use. Let's see how that can be done. But the logic will still remain same, that we just want to have maximum left depth, maximum right depth, and at that node, this will be the maximum diameter I can make. I'll try to maximize my diameter, which means I'll keep a max d as a maximum diameter. I will have maximum of max d comma left depth and right depth. I'll just try to have it like this. Now let's see the trirun, what will happen. So basically initially you were at the node. Now how a tree works, a simple DFS, you first go to the left and then you go to the right. So I will keep on going left. As soon as I reaches the leaf node, okay, again he will try to go to the left. If you go to the left, he will find null. So as soon as you find null, you have to return something. What you should return, you want, again, your aim, maqsad, your aim is that you want to find the left depth and right depth. And to be more precise, you have to find the maximum left depth and maximum right depth. But so for now, just imagine that you have the left depth and right depth, LD and RD. So left depth, he is null. So he will simply say, bro, I'm null. There is no depth whatsoever. Simply return a 0. So I'll simply return a 0 from my null. Okay. Same way, right is also null. So simply right depth is also 0. Now at this specific node, my left depth is 0, right depth is 0. What is the diameter? Again, I will find the diameter at every step, because I'll consider every node as a node which will be the intersection of my left depth and right depth, and that might form my diameter. I'll consider and think for every node like this. So for him, left depth and right depth 0 0, so diameter is 0, and you can also see the diameter is actually 0, nothing. So I know one thing, that so far I'm good. Now simply how a recursion happens, it will go and deliver the value to his parent, because for the parent he has gone to his left child, but he also has to go to its right child. So when the right child value also is returned, left child returned his value, but right child will also return his value, and then the parent will be the node. This will be the left depth for him, this will be the right depth from him, and that can actually form my diameter. But Aryan, okay, you know that this will return something to his parent. What he will return? He will say, bro, you what you want? He want the maximum left depth. For this node 2, he want the maximum left depth to him. For him, the maximum left depth will simply be, okay, bro, you have a left depth. My node 4 has a left depth. My node 4 has a right depth. Okay. So whosoever is maximum, okay, both are same, Aryan, in this case. Okay, no worries. If both are same, just okay, take one and just add a +1. Take one and add a +1. So both are same, which is 0 0. Add a +1 and it will become a 1. Aryan, I didn't understand it. No worries. That's the reason I made a bigger example for you to make it understand. Cool. So actually what happened is that and again, I asked you, take a maximum out of these two. You take a maximum, which means let's say you took this, you added a 1, you are telling my node 2, bro, what you can consider as left maximum depth as this specific portion, which means I gave you my left and right maximum, and I added +1 for a path between 2 and 4. This is a +1 and this is maximum of left or right. Then for you to bro, whose value is 2, the maximum left depth will be this specific path. For us it is right now 1. So left depth has become a 1 for my node 2. Okay, same I will go and do about for my node 2 right depth. Again, you will see it will go down. For him, there is no left depth is 0, right depth is 0. He will return maximum possible value. For him, he will return a maximum value. You can see both are same, 0 0. So he'll add a +1. He will say, okay, bro, right depth is 1, left depth you can see is still a 0. So he will say, bro, I can return a maximum value. So he will return again right depth, left depth. Right depth is maximum, so he will return, okay, right depth +1 as the maximum value. Again, you will also still keep on computing the diameter at every step. At 5 also you will compute, okay, maximum diameter is, currently it was a 0, then which means maximum of maximum d comma left depth plus right depth. You will still compute. Again, just wait for this step and then you will get everything clear. Now, so you will just have maximum depth was earlier a 0 itself, nothing was there. Then maximum left d, it is 0, right d, it is 1. So you can simply see currently so far my diameter, maximum diameter is 1 itself. Okay, no worries, bro. But still, for explanation, I have not written that above, but diameter you will find at every step. Now, he has to return something to his parent. Again, he will go and ask maximum of left and right, and then he will return the maximum of right. Okay, maximum of right is written, but adding a +1. plus 1 I added, it became a 2. Again, what it means is that he asked, my 5 asked, I have nothing in my left, but I have this in my right. For sure, for my node 2, he can have only one path. My node 2 can have only one path. Either he could have had this path itself, that's completely fine. But I want for my node 2 maximum right path. So I want only one path. So this node is plus 1. This node is plus, his edge is plus 1, and then whatsoever my node 5 can give a maximum. Either he had this big path in the left, then he will say, okay, my left depth is good, so give or take this maximum left depth. Or currently in this case, his left depth is 0, but his right depth is 1. So he will say, bro, my right depth is 1. It is big rather than my left depth, so you should take my right depth, because I want my parent to have the maximum right depth. So plus 1 is added for sure, and this is the maximum depth for my node 5, which is the right depth itself. So I'll simply say your right depth, bro, for my bro 2, because my parent is always a bro. So for my bro 2, the maximum right depth is a 2. Now, for currently at my node 2, my node 4 said, okay, your maximum left depth is 1. Node 5 said that your maximum left depth is 2. Now, at node 2 also, I will again go and find the maximum diameter, because I told you, you will have to go and find the maximum diameter at every node. So at node 2, I will go and simply say maximum diameter equals maximum of, earlier we saw that, okay, we had made diameter as 1 itself, maximum diameter of 1 itself. Now, LD, maximum LD is 1, maximum RD is 2. Left depth and right depth, it will become a 3. So far maximum diameter has become a 3, and that is this specific diameter. And you saw, you are actually passing the values of left D, right D to your parents for him to not compute this again and again. Now, again, what will happen is that you were at 2, you again have to pass, again, 2 is computed. You compute this at 2. Again, 2 has to pass something to his parent. What he will pass? He will pass the maximum depth after 2. He saw that, okay, my left depth is 1, my right depth is 2, which means, right depth, I have to pass only one depth, because I know from my parent I can only go into one direction. That's it, because other direction is on the right side. So it's a tree, so I can go only in one direction. Okay, one direction. So, and I want the maximum left depth, so I will return, okay, from 2 I will return the maximum of left depth and right depth plus 1 for this specific edge. And okay, you can see maximum of right depth is 2, so I have added 2, and plus 1 for this edge, it became a 3. So now you saw that plus 1 and 2 is for 1 and 2, this specific path. So maximum left depth has become a 3. So my node 2 has given the value to his parent, which is 1, a left depth of 3. So now you can see the left depth of node 1 has become a 3. And the same way, you will keep on computing the right depth also for node 1, because okay, a node, he will firstly go on to his left and then his right. Left, when it came back, he returned the value to his parent. Right, he will go, and then when he come back, he will again return back to his parent. Okay, come back, you will simply come back. Now it will be a 2. So simply again, you will go and compute the value at 1. What is the maximum diameter? You will see, okay, maximum diameter so far you had computed as 3. Okay, 3. And then left depth, you saw it is 3, right depth it is 2. Left depth is 3, right depth is 2. Then you have got a 5 as diameter. So now your maximum diameter has become 5, and then just keep on computing that, which means, okay, again, this one will return something to his parent. What he will return? He know that his LD was his LD, if you remember, his LD was a 3, RD was a 2. His LD was a 3, RD was a 2. He will again choose the maximum one and then add a plus 1 for this specific edge, and then simply return to his parent or give to his parent. So his parent will have a LD equal to 4, because he know that 1, 2 and 3. 3 was the maximum for the left part, and plus 1 for the edge between 1 and 8. And that's how I can simply keep on computing and finding the answer, and thus I can simply get this done. Cool. Again, if you had not known, like if you had not got this, I'll highly recommend, please go and watch from this portion, because this was the specific part at which you should start getting things. Cool. The code is pretty simple, exactly very same as what we saw, that we have to get this maximum diameter the ask of the question, and then we are doing a simple DFS, Travis. Simple DFS. In the simple DFS, we saw that if my node was a null, then I simply returned a 0. As in the very beginning, I told you that, okay, if your node was a null, you were at this specific node, right? If you remember, you were at this specific node. Your node is null and left is null, right? So it should simply give a 0. So LT should become ideally a 0. So, okay, if something is null, simply return a 0. Else, in a simple DFS, go on to left, go on to right. Okay, I'll simply go on to left, go on to right. Right, and my maximum diameter, okay, my maximum diameter is maximum of existing maximum diameter, which is a global variable which I have defined here, and maximum left depth and maximum right depth. So ultimately I can store this maximum left depth and maximum right depth here itself. So when I'm calling my left and right, I can store that maximum left depth and right depth. But Aryan, which means that while returning itself, you should return, because this DFS function should ideally return the maximum depth, right? Okay, yeah, that is absolutely correct. So I know that I will simply find this maximum diameter as I showed you above also, but while returning itself, I should return the maximum depth, because this is actually returning maximum left depth and maximum right depth. So ideally I'm returning a maximum depth. What is the maximum depth? For me, if I have a node like this, and I have to return something to my parent, I'm returning what? I have got my left depth, I have got my right depth, I'm returning maximum of left depth and right depth, and then adding a +1. That is what I'm returning to my parent. So I will take a maximum of left depth and right depth and add a +1 that I will return to my parent. And that's how you don't have to go again and again to find the maximum of left and right depth again and again, because your child itself is returning those values to you. And that's how your time is O of n, because you are going on to all the nodes exactly once. And also space O of n, because in the skew tree, the recursive stack can go very deep, as in like deep. Cool. So that's a recursive stack space which you will take. Cool. Thanks for watching. Bye. Take care. Again, this question is not an easy question, and it has been asked by many companies. So please do listen to this, or basically understand this question very carefully. Bye bye. Take care.